have a look at a problem on a full wave rectifier with the diodes, and where the value of the load resistance is just 50 ohm and it is supplied by a source voltage. The value of the source voltage is given as 175 sine 2 pi 60 into t. The frequency of the supply voltage is 60 hertz here. And now if we want to calculate the average value of the output voltage and current, RMS value of the output voltage and current, and then average and RMS value of the diode currents, the current flowing through every diode. First of all, let's have a look at the voltages and currents that we see in the full wave rectifier. In the case of a full wave rectifier, you will ensure that the diodes are arranged in such a way that during the positive and negative half cycles of the supply voltage, I'm basically feeding only positive supply voltage to my resistance. Means during the positive and negative half cycles of my supply voltage, I'll be able to get only positive half cycles across my load resistance. Now, if your load resistance is receiving this voltage, then the current flowing through the load resistance will be the same voltage upon the resistance, but it will be just lesser in magnitude, provided that the value of the resistance is greater than 1. But we know that the diodes are conducting in such a way that the couple of diodes will be conducting for the positive half cycles of the supply voltage, means the current will be flowing through those two diodes. That we have indicated here is that D1 and D2 will be conducting during the positive half cycles of the supply voltage, and D3 and D4 will be conducting during the negative half cycles of the supply voltage. Now, if you want to look at the current flowing through any one of the diode, let's say D1 or D2, because they will be conducting in the similar times, then you can consider that the value of the current flowing through those diodes will be exactly same as the current in the case of a half wave rectifier. I'll come to that point later. Now, for now, if you wanted to calculate the value of average output voltage, then V0 average is Vmax upon pi. Since it's a full wave rectifier, then it will be 2 times of Vmax by pi. Now we know that the value of Vmax is 175 divided by pi. If you want to get the output current average, then that is going to be 2 Vmax by pi multiplied by resistance in the denominator. So then this is going to be 2 times of 175 pi, whereas the value of the load resistance is 50 ohm for us. So if you calculate these numbers, you'll be getting this as 111.408 volts, and this value is going to be 2.228 amps for us. Similarly, if you want to get the RMS value of the output voltage, here the output voltage RMS value is going to be Vmax upon root 2. That is 175 upon root 2. Then the RMS value of the output current, that is I0 RMS, is Vmax upon root 2 times of R, which is 175 by root 2 times of the value of the resistance we have is 50 here. So if you calculate these numbers, this is going to be 123.74 and this is going to be 2.474 amps for us. So these are the average voltage and current and RMS voltage and current output of a full wave diode bridge rectifier. So if you wanted to calculate the average and RMS values of the diode currents, as we discussed, this average values of the diode current and voltage will be similar to that of the diode bridge rectifier, that is only half wave. Now, if you look at the output current, average value and RMS value of the half wave rectifier, that is I diode average, that is any diode in this particular circuit, is going to be Vmax upon pi multiplied by R. Value of Vmax for us is 175 pi, whereas the value of the resistance here is 50. Similarly, I diode RMS is Vmax upon 2 multiplied by R, which will be 175 2 times of resistance is 50. You'll be getting this as 1.11 amp and this value as 1.75 amps.